Given question, a cantilever with uniform rectangular cross section having width is equal to 0.15 meter and depth is equal to 0.3 meter. Calculate maximum slope and maximum deflection. Second, slope and deflection at 2 meters from the fixed end. Take E is equal to 210 giganewton per meter square.
To find out slope and deflection at any given point by using double integration method, we have to first draw the free body diagram. We will find out the bending moment at any section XX. So we will show the section XX from a fixed point A. So I will show here the section XX. Now we will extend this section X in the free body diagram, and it is at a distance X from this fixed end A. So we will show here this is the fixed end A and here is free end B. Now what is the remaining distance? Now if we observe the total length of the beam AB is equal to 3 meter. So remaining distance we have to show here 3 minus x. Now we will draw the free body diagram. So first we have to find out what is the load in between this section XX and the point B. If we observe, uniformly distributed load is given 2 kilonewton for 1 meter, but our length is 3 minus x meter. So I will write here for a length of 3 minus x meter what is this load. So here is the question mark. So we have to multiply this, that is 2 into 3 minus x divided by 1, that is 2 into 3 minus x. So this is the total load in between section XX and this end B. So where is the point of application of this load? So it is at the center point in between these 2 points. So I will select here one center point and I will show this load 2 in bracket 3 minus x. Now we will also show the distance of this point of application of the load. So I will show here this is the center point. So how to show this center point? So this distance is 3 minus x divided by 2 and here is 3 minus x divided by 2. Now at point B there is 3 kilonewton load acting in the downward direction. So we will show this point load 3 kilonewton. Now this is the free body diagram. Now we will apply the bending moment at section XX. So there are two loads. So how to show this bending moment? So suppose the direction of this moment is in clockwise direction, then use negative sign, and if it is in anti-clockwise direction use positive sign. So this is the sign convention. Now if I move the compass about section XX in the direction of this load, that is in the downward direction, then there is clockwise direction. So we have to take this load multiplied by distance. So this distance is 3 minus x by 2. So we have to use this negative sign. So minus 2 into 3 minus x multiplied by 3 minus x by 2. So if we simplify this, then we will get minus 2 into 3 minus x square divided by 2. Now we will move to the next load 3 kilonewton. So it is also in clockwise direction. So minus 3 multiplied by 3 minus x, and we have to write this. Now we know that the bending moment at any section is equal to EI d square y by dx square. So suppose this is the equation number 1 and this is the equation number 2. Then both these equations are same. So I will equate this right hand side. So we will get the equation EI d square y by dx square is equal to, now this 2 is getting cancelled. So minus 3 minus x square minus, now I will multiply 3 with inside the bracket, minus 9 plus 3x. Now again we will simplify this bracket. So it is a square minus 2ab plus b square. So a square is 9 minus 2ab minus 2 into 3, that is minus 6 into x, minus 6x plus b square, that is x square, and here minus 9 plus 3x. So if we multiply this negative sign inside the bracket and if we simplify this, then we will get the equation ei d square y by dx square is equal to minus 18 plus 9x minus x square. So this is the equation number 3. We are using double integration method. So we have to take the integration on both the sides. So it will become ei dy by dx. So we will write here, therefore ei dy by dx is equal to, now we have to take the integration. Now we know that integration of x raised to n is equal to x raised to n plus 1 divided by n plus 1. So here it will become minus 18x. Now what about this plus 9x? So here x raised to 1. So if we consider n is equal to 1, then it will become x square by 2. Minus, now here instead of n there is 2, so it will become minus x cube by 3. And we have to take the constant of integration plus c1. Now how to find out the value of c1? So if we observe the diagram, at this end a, x value of x is equal to 0 because the distance x will start from this fixed end. So here x is equal to 0 and slope is also equal to 0. At the fixed end, slope is also equal to 0. So in this equation, this dy by dx is known as slope. So we can say that at a, x is equal to 0, dy by dx is equal to 0. Now when we put x is equal to 0, then this whole term will become 0. dy by dx is also equal to 0. Therefore c1 is equal to 0. So how we can get the slope equation? Therefore slope equation is equal to ei dy by dx is equal to minus 18x plus, now this 9 divided by 2, so it will become 4.5 x square minus x cube by 3. So this is the slope equation. In question, we have to calculate the maximum slope as well as slope at a distance of 2 meters from this fixed end A. So how to show this slope? So with the help of diagram we will understand this. So because of this uniformly distributed load as well as point load, this beam will deflect about this fixed end, and here is the deflection. Now how to calculate the maximum slope? So maximum slope is at the free end B, and what is the value of x? So x will start from this fixed end and value of x is equal to 3 meters, and we have to also calculate slope at a distance of 2 meters which is at the fixed end. So we have to take x is equal to 2 meters. So to calculate maximum slope we will take x is equal to 3. Now how to show this? So here this slope is measured in terms of angle theta. So here is the angle theta, and for B we will consider it as a theta B. So to calculate theta B we will use the slope equation. Instead of dy by dx we will use theta B. So ei theta B is equal to, and instead of x we will put x is equal to 3 meter. Now how to calculate the value of I, that is the moment of inertia. So in case of this cantilever beam AB, width and depth is given. Width is B 0.15 meter and depth is 0.3 meter. So I is equal to BD cube by 12, and therefore it is equal to 337.5 into 10 raised to minus 4 meter raised to 4. So value of E is also given in the question 210 giganewton per meter square. So standard unit is Newton per meter square. So we will take 210 into 10 raised to 9. Instead of I, we will use this calculated value in terms of meter raised to 4. And if we observe this right hand side, then we have used the load in terms of kilonewton, but standard unit is Newton. So we have to multiply this numerator with 10 raised to 3. Now when we solve this, then we will get the answer minus 3.17 into 10 raised to minus 6 radian. So this theta b will be measured in terms of radian. Now how to calculate the slope at x is equal to 2. So instead of x is equal to 3, we will use x is equal to 2 and we will use the same method. Now we will find out the deflection equation. So to find out deflection equation, we have to take the integration of the slope equation. So again I will write here integration on both sides. So this equation will become EIY is equal to x cube by 3. So here minus 1 by 3 we will write as it is because it is constant, and we know that x raised to n is equal to x raised to n plus 1 divided by n plus 1. So n is equal to 3, that is x raised to 4 divided by 4 plus 4.5 as it is, then x cube by 3, then minus 18 as it is, and instead of x we will write x square by 2, and here constant of integration we will consider as C2. Now we will simplify this equation, so it will become minus x raised to 4 by 12 plus 4.5 by 3 x cube minus 9x square plus C2. Now how to calculate this value of C2? If we observe the diagram, at fixed n, x is equal to 0, slope is equal to 0 and deflection is also equal to 0. So this deflection is shown with this y. So y is known as deflection. So when this x is equal to 0, then y is also equal to 0, that is this is at point A, and these are known as boundary conditions. So when we apply these boundary conditions, then if we put x is equal to 0, then y is equal to 0, then C2 is also equal to 0. So in this equation C2 will become 0. So we will get the deflection equation. So put the C2 is equal to 0 and remaining will be deflection equation. Therefore deflection equation we will write, therefore EIY is equal to minus x raised to 4 by 12 plus 4.5 by 3 x cube minus 9x square. So this is the deflection equation. Now we will calculate maximum deflection. So maximum deflection will be at the free end, and this deflection is in the downward direction. So we will show this deflection with the help of diagram. So here is the original position at point B, and here is the final position B dash. So this B to B dash is known as deflection at B, that is YB, and it is also known as maximum deflection. So in this deflection equation, this y indicates the deflection. So when we put x is equal to 3, then this y will become y maximum. So this is the maximum deflection. So we will solve this as it is. So put x is equal to 3 on the right hand side and the value of EI. So E 200 into 10 raised to 9 and I is equal to 337.5 into 10 raised to minus 4, and we will transfer this term to the right hand side. And if we observe, we considered the load is in kilonewton. So for this right hand side we have to multiply with 10 raised to 3, because load is always, that is the standard unit of load is in Newton for the calculation. So multiply this bracket with 10 raised to 3. So when we solve this, then we will get YB is equal to minus 6.66 into 10 raised to minus 2 meter. Now why this negative sign? Because the deflection is in the downward direction, and therefore this value of yb or y maximum is having negative sign.